In this tutorial, we're going to take a look at finding some surface areas and volumes for some common three-dimensional solids. And in the first one, we're asked to calculate the surface area and volume. Some of these will be both, some will be just one. So this one asks for the surface area and volume both for this cylinder. And then the question is certainly after you find the volume, you can answer this. How much water would the cylinder hold? So we'll get into that. So let's do the surface area first. There's the surface area formula. We are told that this is 9.5, so that would be the radius. So that's going to go in place of r here. And the 23 is the height. That's how long the cylinder is. So 23 is going to go in place of h here. And of course, 9.5 is here, but it's also here. So this is what it looks like when we substitute 9.5 for r and 23 for h. And I'm going to bring my calculator over. Now, you actually can do this all in one shot if you want. So there's my 2 pi. And you can go 2 times pi if you want to. Times 9.5 times 23. So this first part here is going to be 1372.9. And let's do the second part. So 2 pi again times 9.5 squared. So 9.5 squared. So what's on the end here is about 567, about 0.1. So that's those two numbers. And of course, if we add those two numbers, we get about 1940. I do want to show you that you can do this all together. So let's say, okay, so what I have in the calculator now is this, and you could go plus 2 pi times 9.5 squared. And so, see, there's the 1940. This would round to 1940. So if you're good enough to do that, you know how to your calculator works well enough, you actually could do that in one calculation, not necessarily having to do these separately. So volume now. So this is the volume formula for a cylinder. Volume is pi r squared times the height. And of course, same radius, same height as over here. So we would fill those all in. And of course, here's my calculation. Times 9.5 squared times 23. So we're going to get about 6,521. Now, you can do this all separately if you want. You could like square the 9.5 and go pi times that 90.25 times the 23 if you wanted to. And of course, you will get exactly the same value. So the volume is 6,521 cubic centimeters, and 1 milliliter is the same as 1 cubic centimeter. So we could also call this, we could also call the volume 6,521 milliliters, or about 6.5 liters. If you want to keep more decimal places, you could call it 6.521. I just rounded to the nearest tenth, so I dropped the 21 here, but it's about 6.5 liters that would hold. Number 2 here, determine the volume of the cone. So this is just volume. So here's the volume formula for this cone, and so we're told the radius is 3.7 and the height is 5.2 here. So we're going to fill those into the formula. So r is 3.7, h is 5.2, and so back to the calculator again. So in the numerator on top, times 3.7 squared times the 5.2. So that's what's on top, and then of course we're going to divide that by 3. So we'll take that 223 and divide it by 3, and so we get about 74.5. Now it's really not necessary for you to do this number separate here and then divide to get 74.5. You actually can, so let's clear this. Let's bring back. Okay. In a TI-83, if you go second the enter button, again and again and again, it goes back to the next step, the one before, the one before, the one before. So that's my numerator expression here, divided by 3. So I can just do that. I don't really need to do the 223.6 number, but I'm just showing how the calculations are done, so I'll include a few extra steps here. Example number 3. You're asked to find the surface area and volume both for this one, for this rectangular prism. And so here's the surface area formula. And I'm going to use the length is 38, the width is 12.6, and the height is 30. If you want to do those different, if you, for example, want to use the 38 for the width, the 12.6 for the height, and the 30 for the length, it's going to give you exactly the same answer. It doesn't matter where you put those numbers, as long as, you know, 2 places you put an L, 2 places you put an H, and 2 places you put a W. So substituting those in, so the width is 12.6, the length is 38, and so 12.6 here, and the height is 30, and 2LH, so the length is 38, and the height is 30. And again, we can do all these separately, so at the beginning we have 2 times 12.6 times 38. So that's that first number. In the middle we have 2 times the 12.6 times 30. So the middle number is going to be 756, and in the end we have 2 times 38 times 30. So those numbers will all get added. Let's bring the calculator a bit. So there's those numbers, 957.6, 756 in the middle, and 22A in the end. And of course, if we add all those up, we get just under 4,000, so 3,993.6, and its area, surface area, so centimeters squared would be the units. So volume now. So here's the volume formula. Volume of a rectangular prism is just length times width times height. So bring the calculator back here again. So length times width times height, so it's 38 times 12.6 times the height of 30. So we should get 14,364, and of course its volume, so it would be centimeters cubed. So that's the volume of this rectangular prism. Number 4, we're asked to find the surface area and volume both for this pyramid. So here's the surface area formula. The 2.5s on the bottom here, there's the base dimensions. They're called the B's. So that's B. This is a B here. Equals. And this is actually the height. H is about 4. So the formula, so this is the area of the base, and this is actually the 4 triangles. 2AB is actually it's a simplified version of the area of the 4 triangles. Now what A represents is it's the slant height along here, along the side. So I'm going to redraw the pyramid, and so this is A right here. And so I'm drawing a right angle triangle. This is kind of right in the middle of the pyramid. So this is one side. The 4-meter height is one side. And the base here, well, that would, since it goes from the middle out to a side, that would be half the length of the B here. So that's why that's 1.25 meters. So we can find that A value by using Pythagoras Theorem, because this is a right angle triangle. And A is the longest side because it's across from the right angle, so it's the hypotenuse. So A squared would equal 4 squared plus 1.25 squared. So here's my Pythagorean theorem. And so if I square, 4 squared is 16. Maybe I should bring my calculator back here again. 4 squared is 16. 4 squared, 16. 1.25 squared is that number, 1.5625. So I'm going to take that and add 16 to it. So it's 17.5625. And then, in order to find A, so A squared is that, we want to get rid of the square here. The opposite of squaring is to take the square root. So the square root of this 17.5625 number is about 4.2. So the A side is about 4.2. So we can now fill in our formula here. We already knew that B was 2.5 here and here, but this is 4.2. So filling those all in, and so at the beginning I have 2.5 squared. So this is going to be 6.25 at the beginning here. And then after that we're adding the product of 2, 4.2, and the 2.5. So that's going to be 21. So this is going to be 6.25 plus 21. And of course, if you add those, you get 27.25, and the units would be meters squared. Now, here's the volume formula for the pyramid. Volume is the base squared times the height over 3. If you ever have a pyramid that these two dimensions aren't the same, then we normally just call them the length and the width. So it would be length times width times height over 3. It's actually just the volume formula for the rectangular prism divided by 3. So, but we do have the two dimensions the same. So that's why they're called b squareds there. So filling in the values here, I'll maybe do that first. So b is 2.5, and the height we were told is 4 meters. So we will go 2.5 squared times the 4. So it's going to be 25 on the top, and then we're going to divide that by 3. So 25 divided by 3, and the final answer is about 8.3. So there's my 25 over 3 divided. We get 8.3 meters cubed for the units, because this is these are all in meters. Last example, we're asked to find the volume of a sphere. I didn't draw a diagram for this. A sphere is just a ball. We're told the radius is 12.8 inches. So here's the volume formula for a sphere. So we're just substituting 12.8 in place of r here. So that's what the calculation looks like. So in the numerator on top, it's 4 times pi times 12.8 cubed. So 4 times pi times 12.8 cubed. So that's what's going to be in the numerator, and then we're going to divide it by 3. So that would be the final answer. Maybe we'll move this over here a little bit. Yeah. So there's my 26,353.589 number, etc. Divided by 3, we get 8784.5. And since this was in inches, the volume would be in cubic inches. Okay, inches cubed. And that is the end of the tutorial.